Welcome back, everyone. Talking about now. My name is Milano. I'm talking about pressure-assisted slip casting. It's a very advanced process, and it's quite new. Anyway, although pressure-assisted slip casting is similar to normal slip casting in name, it is unclear whether or not this process remains the same or similar at all. Normal slip casting involves taking a mixture of powdered ceramic and water, known as slip, and pouring it into a mold. The slip takes the shape of the mold, and once it's dry, the mold is removed, leaving the finished product. Where pressure-assisted slip casting differs from normal slip casting is the use of either liquid or gas to create a pressure chamber within the mold, pushing the slip outward towards the walls of the mold. Once the ceramic is hardened, the liquid or gas is removed. The mold is finally removed afterward, and you get the final product. These are just some products made using the normal slip casting process, and you can see you can get quite good detail using this. Here's a diagram of an explanation of how slip casting actually works, normal slip casting. So what happens is a clay powder and water is mixed together, and it's to create a slurry, and then it's placed into a mold, and then the clay starts to harden and it forms on the outer edges of the mold itself, and then once it's hardened to a certain degree, the liquid, the part of the slurry, is removed, and then you have the remaining clay object, and that's known as a green body, which means it hasn't been fired yet, and then it's taken and it's put into a kiln and it's fired, and you have the final ceramic object. Now I went to visit a local Brunswick clay and pottery store called Northcote Pottery Supplies in order to get a glimpse into the process. What they had on offer was unfortunately not normal slip casting and not pressure-assisted slip casting, as it became apparent that the latter is performed more so within a factory environment. Unfortunately, I could not visit or find any factory which does pressure-assisted slip casting due to the outbreak of COVID-19 and quarantine laws enacted by the Australian government. Here you will see a photo I had taken with my phone of the ready-made terracotta casting slip which Northcote Pottery Supplies had on sale. And on the other side you will see products that were made using the normal slip casting process. I had endeavoured to find the mould used to make these products within Northcote Pottery Supplies. However, the man behind the counter had informed me that they did not have any, although I personally believe he was reluctant to go and search for them, as it was a particularly busy day and the storage area in the back of the shop was quite cluttered. I have had extreme difficulty sourcing any information on the novel process known as pressure-assisted slip casting. There is barely any information online whatsoever. Japanese and occasionally Russian study articles from 1992 to 2005 at researchgate.net document a process known as vacuum pressure slip casting. An abstract from a 2005 article reads, a vacuum pressure slip casting technique and hot isostatic pressing, HIPING, were used to prepare high strength and translucent alumina ceramics. A low viscosity and high solids content slurry of 46% volume solid was prepared and a dense green compact was formed. The samples were sintered and subject to capsule-free HIP. Extremely high density 99.9% and fine grain 0.7 to 15 nanometer micrometer in diameter alumina ceramics were obtained. The HIP'd samples show high bend strength and translucency with inline transmittance of 30% to 46%. That's 1 millimeter thick. A similar process known as magnetically assisted slip casting seems to have uses in the medical field, as demonstrated by the image below, where MASC refers to magnetically assisted slip casting. It's quite a long read, so I won't read this out. All this information can be found here at this site. Further research into this collection of articles uncovers a plethora of insightful and fascinating documents. One article documents pressure filtration assisted gel casting in translucent alumina ceramics fabrication. The article reads, high density and homogeneous green body is important for fabricating transparent ceramics inspired by the improved sample's homogeneity in slip casting. We introduced low pressure filtration to gel casting to further increase the relative density and homogeneity of the green body and to shorten the drying time. The effect of pressure filtration on drying characteristics, bulk density and porosity of the pre-sintered bodies in the microstructure and optical transmittance of the resultant ceramics were intensively investigated. The results show that the pressure filtration can reduce the drying time by 27.3%, improving the density of the pre-sintered bodies and reduce the residual pores of the sintered ceramics. The inline transmittance of the translucent alumina prepared by the pressure filtration assisted gel casting was 32.7% at 600 nanometers thick with a thickness of 1 millimeter, which is about 6% higher than that without pressure filtration. In principle, this process can be applied to fabricate any other high performance ceramic. The term grown body refers to any structure formed out of ceramic that hasn't been yet fired or sintered. And this material known as alumina-ceramic garners frequent mention within these study articles. Upon further research, I discovered that alumina-ceramic is also known by its chemical name, aluminium oxide, and its chemical formula is Al2O3. Alumina-ceramic is an excellent electrical insulator and has wide-ranging uses in fields such as electronics and automotive sensors. It is one of the most advanced ceramic materials in use today. The advantages of pressure-resistant slip casting is able to create advanced ceramic shapes, which seemingly have potential uses in advanced electronics, automotive, and medical fields. But the disadvantages of this process is it's relatively an unknown process, and currently seems limited to the medical field and advanced scientific research. Thank you.